Hello humans, welcome again to the Touchdesigner training course. This is the 5th session and today is turned to the Sweet 16 tops. The last session was Sweet 16 shops and today we are going to go deeper in the top family. Some of those operators we already have used it in the previous sessions, but today we are going to see how it works inside our snippets window. So for that we are going to need to go to our Touchdesigner project, and again let's go to help menu and operator snippets. Movie filing. The purpose of this specific operator is to read movies, still images, or sequence of still images. We have 3 different ways to integrate content directly to our system as an import tool in another software that you have used before. So the first thing that we are going to go is to movie filing, and we already used it before. We just have to create an operator and we have this path here where we go and select our content. It's simple, but we are going to see here different ways to use it. In this specific example, they are using loop, stop, and cue. So this movie trim values will keep it looping forever. Its extend right parameter is set to cycle. So in this case, if I click here, I will see the difference between those two. This one is working as a loop and this one is just reproducing once. And if we check what is the difference between those two, is this specific page here, the trim. So the extend right, when it's talking about right, it's the place where the frame is. I mean, if our timeline of the video it's reproducing from left to right, when it finished, what is going to happen? So in this case, it selected cycle. That's why when it's finished, just is going to begin again as a cycle. But in this case, that is just working once, is selected the hold option. That means that when all my timeline inside my video ends, it's going to hold in the last frame. So we have now 2 different ways to use it. The second example is use the slider to screw through the movie by index. So in this case, look, the reproduce of our video is not based in the timeline or in the FPS, in the frame rate. Here we are reproducing, or in this case we are moving inside our frames with the interaction of a simple slider. That is, we already understand how Touchdesigner works. We know that this element can be replaced for any other element that it works with a number. So this can be a sensor, can be a signal from another system through MIDI to OSC. It can be also trigger of behavior of any other kind of element in our installation. So at the end, we just need to find a way to solve the solution that we are looking for. So in this case, the difference here is the way that it's playing. Look, the play mode, it can be locked to timeline. That means that it's going to be working depending of the main timeline of our system. It can be sequential or it can be a specific index. If we select a specific index, this parameter here is going to be the number of our frame inside the video. That's why every time I change this operator here, that it's an slider, it's sent to the mat, changing the range from 0 to 1 and converting it from 1 to 100, because our video has a length of 100 frames, and after that the relation between this operator and this movie file in, it's through the index, and that's why I can change the position of the actual frame just moving this slider. And in that way you are going to find different examples. We're going to see it deeper when we begin with the development. The second operator is ramp. Create vertical, horizontal, radial, and circular ramps. Here in circle, this is just like kind of joke inside our software that it's saying that a ramp, it can be used also to create a circle, but we already have the circle top that is going to create the same. But let's see the other examples. For example, this table. In this table, you can edit the individual values of the ramp via its docket table. Try changing the RGB values in the table. So for example, let's see what's happening here. We have RGB-A parameters. We have 1, 2, 3, 4, 5 different positions, and also have different values here going from 0 to 1. The first here is alpha, just alpha, that I think that it should be here, the black part. The next is of course just red, 0, 0 and 1. 1 because alpha is always on, that means that it's complete. The opacity is always complete, so there is no transparency on those pixels. After that is going to be green, blue and white. So let's see if we want to change this line here, that it's the green. I just need to change the values, and the only one who changed was the green here. If I put 0 again, I have it back, and you can see that this is also changing here inside. But I can create also new steps. If I click here inside my line and I move all the parameters inside while it's select, I can create a new step with a specific color. And it's always going to create or have the information of the blend of the two colors that I'm putting and clicking between. For example, I was inside a blue and a white, and what I'm getting now, it's this kind of light blue. And you can see how now we were finding ways to relate different families, for example, with information that we can understand also as a numbers, can be visualized and represented in a visual way with dots, for example. And you can see that every time I create a new one, here also is another row created, and every time that I change the values, also you can see how it's working here inside also our table. Perfect. The face is a way to move our ramp. For example, let's create a in this case, also when we create a ramp, this is going to be for default just 2 steps, one black and one white. But look, if I move my face, this is also going to move my ramp inside the operator. And also the period is used to change the aspect. When it's talking about periods, it's also that we also can understand as the ramp that I show you here with the trail here the things works as waves, but are just visualized in a RGBA language that it's visual in this case. But look, if I change this and I put it ramp, at the end I'm going to find something similar like this. Also, I can create here a shop to, and look what I'm getting here. I can make it bigger with a constant. For example, I can create a constant here to make it in the same size, and now I can integrate it with an over and see what I'm getting here. It's the same, it's just a ramp, but in this case I'm created since the beginning with pixels, but I can also understand that everything here, it can be expressed in a numeric way. And look what I'm getting here. It's the same level. Adjust contrast, brightness, gamma, black level, color range, and opacity. The first example, black level, brightness, and gamma adjustment. This operates on each red, green, blue, and separately. Refers to the Luma level top 2, which will create the 3 channels together as luminance adjustment, which give better results sometimes as a maintained hue and saturation. Okay, let's see what's happening here. We have this, I like a resource image, and here they are changing the black levels, the brightness, the gamma, and let's see what we found here inside our pages. The first one, it's a pre. That means that is the first step of edition. After that, we have in the middle 3 more pages, and the 5th is post. That means that everything that happens here always will take first as an input what is happening here in this page. It will proceed with these elements, and at the end I can give another addition through gamma, opacity, and brightness. But here we also have gamma and brightness. So it's something that we need to take in mind if we want to work with the elements here in the middle. For example, we also have controls of the specific channel R, G, B, and A. I can take out all the elements with red, for example, and look how the things will be looking in this case. Or I can saturate it more if I want also. The invert is like the same thing that we found in any other software that works with pixels. The opacity, for example, here the opacity will just find it in post. We don't find it in pre. So this is also one way that we can begin interacting with our system and with the images. That we can begin editing images in real time in a really simple way. So, for example, if we want to create a strobe, we can create a constant. After that, we create a level. And a strobe, it's just a light that go on and off fast, right? So I create an LFO. Now I have just to relate this operator with the opacity, and every time that I change the velocity, I will have the effect that I'm looking for. For example, if I'm a strobe. Also, I can stop it, but I need to understand that this behavior here depends on the behavior of this number inside the LFO. Okay, here for example, they are changing elements here inside the RGBA, but in different ways in all these examples. So this is the result that we can get if we change these parameters from just one single still image. And there are so many other examples to check. The next is transform. Translate, scale, rotate, multi-repeat tiles and background fill. The transform, it's also one of those operators that you will use a lot if you are working with 2D content. For example, here we are seeing how can we change the way to rotate something, just taking in mind the pivot. We already saw that all the elements here in the tops always have the coordinates with positives and negatives values. From the center to the left and to the bottom it's negative values, and from the center to the right and to the top are positive values. So here both of the operators are rotating, but the first has the pivot right in the middle, that's why it's rotating in this way, and the second is rotating with the pivot in 0, 0. That means that it's here in the very end of the corner. The second is the transform order. The transform order is crucial for assigning the order of the transformation top operators. Transform 1 defaults rotate first, then translate. Transform 2 via transform order menu translate first and then rotates. So here we have two different ways to understand the transforming. Here the first parameter says transform order, scale, rotate and translate. And here it's translate first, after that scale and rotate, and we can see that they are changing different parameters. We can click here at the corner and we can see what are the parameters that they change. They change the translation and they change the rotation. Here, for example, they have first a scale, they are not scaling it, they are rotating it first, and after that they translate it. That's why this element is moved 1.3 to the right, and after that is rotating. But in this case, our element was first moved because translate is first, and after that it rotates, but it is still with the pivot in the middle. Here the pivot is in the middle of the element, and here the pivot is in the middle of the area. So this is also another way to understand how we have to work with pixels. The next is over. Place and shift one image over another based on the alpha of one image. The over, as I told you, is the way that I understand this, is how we create layers. Those layers are in the same way that it works in Photoshop or in Illustrator. So the only thing that we need to understand is that it will always need to be defined the first operator, the first parameter, to take in mind what is the most important input. So if we select input 1, it's going to take the resolution of the first input, but if we take input 2, it's going to take the resolution of the second input. And by default, it's always created with the second input selected. So here the prefit parameter gives you the various options to how the composing will occur. So here they select fit best, and that cancel the next two parameters, and what's happening is that this is always going to be on the bottom. If you can see, it's connected also the second connection here and here, and the first is this butterfly that it's on top. That's why you can see it on front of the background. So here, when they used fit best, you have to see that it's taking in mind all the background, that it's also transparent, and it is also conserving the same resolution and the same aspect. It's not deformed, because by default it's always feel like this, but when you select fit best, it's going to keep the aspect in both content. And here they are using native resolution, that it's a really small resolution related with the background, and they are changing the rotation and the translation to put it in a more natural position. We also can see here the example about the resolution that I just told you. Is always taking in mind the resolution of the parameter that you select. Is you select that the input 2 is going to be the fixed layer, this is going to be the same resolution as the other. But if you select the first, look, now we have here 512 and here we have 512. The next operator is text generation with variety of fonts. We also saw it in the last session, but anyway, we are going to check it here. Text. As I told you, there are so many ways to integrate our information to the text operator. This is one of them, where we use a dat in the dat parameter, where if waiting for any dat operator that has text alphanumeric elements, the table that is something similar, but you can change and select rows and column to determine what is the content that is going to be here visualized. Based in shops, for example, you can create conditions, bring the information inside the text, for example. You can use external OTF. You just need to go and find the path of your font. You can format various aspects of the text. As I show you, there are so many parameters as any other software: bold, italic, the size, the tracking, the kerning, the position, the line spacing. You can also play with colors. You can put colors to the font, to the background, to the line, to the second line, to the borders. The next is the blur. It's really simple. Actually, it's just a blur generator. We'll see here different ways and different methods that it has to make blurs. For example, the simple blur. Here, it depends of different parameters. Here, the filter size is what it changed our blur. For example, we can make blurs using a method that it can create different directions of our blur. For example, here we are using a blur that it changed in the x-axis, and this is using the method or horizontal and vertical. The only thing that we need to change is the position of our sample step. You can put it in X or Y. For example, here they are using VY. If I extend it, it's going to blur just in that axis. I need to change it here, for example. And you will find different. For example, here you can make just one channel blur. They are using here blur just in the red channel. For example, I can make it just in the green, and all the other pixels will hold. It's useful to make, for example, glows or those kind of things. The next operator is composite. Combine multiple images with variety of operators like under and difference. Look what it said here. After you look at the examples here, get the example dialog. Tools called blend mode. Let's go there and check what it is. Blend modes. Look here. And look what we have here. This is a little tool that they created just using the com operator, and this is the way that we can integrate two different content. For example, let's create here a movie file. So there by default is the background of the clouds, and if I want to interact with this tool, I just need to activate it. And for example, I can make a blend between those two. I can change the blend mode that I want. Look what we have here. But at the end, this is just a tool that makes it easier to see what's happening and what are the options of two elements. But if I want to do the same, I just need to create a composite. I create here a movie file with the first, create another movie file with the second content, that it's the cloud, and I change here in the list, and you will see all the same options that they are showing here. The next is render. We already saw how it works. Here the render, they show it with all of those different examples. They are showing how is a basic render. We just need a camera, a light, an operator with geometries, and a font. We also can find different ways to create shadows based on our 3D objects and also our real-time look. If I rotate it here, this element, we have two different lights, and this is going to create the proper shadow based on the position of those lights. We can also get deep information from our 3D objects using the depth and the render, and there are so many other options like rendering in cube map or rendering in fisheye. We will see it when we work more deeply in render elements. The next is Shop 2. Convert shop channels into scan lines of an image. Shop 2 here. Look what it's doing. For example, this example used the RGBI values from top wall to create a pixel. So they use this image. After that, they put it in a top 2, and what it's getting is the information of one of those pixels here is in the middle. Look, if we move this here a little bit, what is happening here is that with those two parameters we are choosing one of the pixels here inside, and this information, it's being expressed in 4 different channels. What is the value in red, what is the value in green, in blue, and alpha, for example. So that is the way that we can translate the information from one pixel to numbers. If we try to do this with all the pixels, it will be a lot of information visualizing numbers, and it's not going to be really good for the processing of our system. We can also express information that are numbers, and after that this can be interpreted also in pixels. That's happening here, that everything that is white it's because it's more to the top here in the 1, and everything that is black is more to the bottom, everything that goes to the 0. Or also you can have multi-samples, and for example we can see also the way that we can integrate information that it's being expressed in numbers into a pixel, but this is not to create images, it's to transport information. For example, we have here one kind of pixels that are 32-bit float RGBI. That means that every pixel can have 32 bits inside in every one of the channels. The next one is resolution. Change the resolution of an image and smooth filters down. The example brings the resolution down to 1/4 of the original value. So what is happening here? We has an input. We connected here. We have here 1280 by 720, and here we have 320 by 10080, sorry. So that it changed just here in the first parameter. This element has 1/4 of the resolution. I can change it for an 8, for example, and look, we also can see here the resolution of both. We can use a half, so the half of 1280 is 640. If we use 8 again, 1/8 of 1280, it's 160. And you can also use custom resolution and you decide, but you need to also take one in mind. One thing is the resolution and another thing is the output aspect. Here you can see the things that the size is the same in width and height, but the aspect is still 16 by 9. So here in the output aspect you also need to select resolution, and now this is going to be a square. The next is cropped. Crop the image to smaller resolutions. You can see here, for example, we have a image 512 by 512, and they are cropping here the things in different sections. How the crop works. So we have a movie file in, and we have the crop. The crop has just 5 parameters: crop left, crop right, crop bottom, crop top, and what is happening when there is no information. In this case, is repeat. So what we're going to do, if we move crop left, this edge is going to move based on the position of my slider. But we need to look here what's happening here in those bottoms, in those menus. Here we have a range from 0 to 1. So this is taking in mind the fraction based on here is 0 and here is 1. That's why crop is positioning in 1. If I move to this side, it's going to move to 0. The same happened with bottom. Bottom is 0 and top is 1. If I move top, this is going down. It's going to 0. But it's because it's working by fractions. If I use pixels, now this is going to take in count the numbers of pixels. Now is 300. If I move just 1, this is just going to crop 1. If I move 150, this is going to be cropped by half. So this is the way that it works with the crop. The next operator is the select. Select an image from the same network or a different network. So you can see here we have an input, we have a null, and here we have the same content that is here. If I change it here, it's going to change also here. So this is one way that we can grab information from another network or from another operator without any connection. For example, here is happening the same, but the information is coming from inside the container. Inside we have this element, and we also have it here. And this is even deeper. This is here inside. This is the element that it's being selected here. You can see level 1, level 2, banana. Level 1, level 2, banana. The next is reorder. Reorder the channels of an image. So look what is happening here. We have an operator that is reorder, that it has multiple inputs. The first is the source 1, source 2, source 3, and source 4. And look what's happening here. First is the video with our loop. The next is just an image that it's being animated for the second connection, and it's still in the third. And the fourth is the butterfly. Everything is bringing here, and what you are doing here is to select what you are going to keep from every input. For example, output red is just going to take in mind what is being in the input 2, and is going to keep the channel red. Input green is going to keep the input 3, and it's the same with the blue. For example, here you can see that just the blue pixels are the pixels of the video, and the same for the element that it's rotating here, that is connected to the second. It just has red pixels because it's selected here. And there are so many other examples that you can check, and everything is related of how you want to use your channel independent in the image. And the last one is displays. Use red, blue of one image to wrap another image. Displays. And we have the network that we always find in the beginning. So the displays is always taking the red and blue channel to display the whole image that is being connected in the first input, and the displacement is based in the second input. So you can see how this wave is being interpreted in pixels, and with the same way that it's moving here inside, it's also displacing here as a result. You can see it also in still images. So here you can see how it's displacing based on this ramp. Also can be displaced by noise. So we have here the first input, the noise in the second. And you can see how it's getting that noise. It's also a noise. And this is everything for now. So I hope that this is giving you a lot of ideas, and you can understand more the possibility with our operators. Now my invitation is that we can keep developing, and let's see what we are going to get in our workshop. See you there in the video call. Thank you.